Hello friends, in the last video we have started exercise 1.1 and I think we have completed first two questions. Now we are starting example from question number 3. Before that, hope all of you have gone through all these formulas. Here even with these standard formulas I have written product rule also and quotient rule also. Now using these formulas and these rules we are solving the example from question number 3. So total 20 examples are there in this question. So let us begin with the first question. So let us differentiate the given function with respect to x. So differentiate it with respect to x. So dy upon dx will be equals to. So since we are observing the differentiation, so since we are finding the differentiation, so observe the terms here. Here two terms are connected by what? Plus. Means we have to apply addition rule. According to addition rule, first find out the differentiation of first term. So observe the first term is in the form of, it is in the form of f of x raised to power n. Means apply first formula to find out differentiation. According to this formula, first take this power as an coefficient, then decrease power by 1. This is your f of x raised to power n. We have taken power as an coefficient, then decrease power by 1. So what will the new power? Existent here power is 3, new power will be 2. Into derivative of f of x. What is f of x here? Here f of x is nothing but x square plus 4x plus 1. Plus keep it as it is. Now we are finding differentiation of second term. If you will observe here, second term is also exactly in the form of first formula, that is in the form of f of x raised to power n. Here also first take the power as an coefficient, then decrease its power by 1, x cube minus 5x minus 2 raised to power. If we are decreasing power by 1, new power will be equals to 3 into derivative of f of x. Derivative can be denoted by d by dx. So here f of x is x cube minus 5x minus 2. So which is equals to, keep these 3 as it is, keep this first term x square plus 4x plus 1 whole bracket square also as it is. Now we are finding differentiation of this term. So observe the first term x square, a derivative of x square is 2x plus derivative of 4x will be 4 and derivative of constant term will be equals to 0 plus 4 keep it as it is, keep this term also as it is, x cube minus 5x minus 2 raised to power 3 keep it as it is. Now we are finding differentiation of this term. So observe that first term is x cube. What is the derivative of x cube? Take the power as an coefficient, decrease power by 1. Derivative of x cube will be 3x square and derivative of minus 5x will be minus 5 and derivative of this constant term will be equals to 0. Now differentiation is completed. Now remaining part is just simplification part. So keep this x square plus 4x plus 1 as it is, whole bracket square also as it is. Now if you will observe this term, can I take 2 common from these two terms? If we are taking 2 common, then 2 into 3 will become 6 here. And if we are taking 2 common, what is remaining term here? X. And if we are taking 2 common from 4, so here remaining term will be 2. Here nothing is there to simplify. So keep this term as it is. 4 into x cube minus 5x minus 2 whole bracket cube x 3x square minus 5 also as it is. In this way, we have seen the differentiation of this given function. So now let us try to solve the example number 2. So given function is already written here. We are differentiating it with respect to x. So dy upon dx is equals to. If you will observe the given function, here product of two term is there. Product of two term is there means we have to apply this product rule. According to product rule, keep first term means u as it is into derivative of v, means first term as it is derivative of second term plus second term as it is into derivative of first term. Here this will be our first term and this will be our second term. So we are applying product rule here. According to product rule, keep first term as it is. So first term as it is into derivative of second term, where second term is 3 plus x minus x square raised to power 8 plus second term as it is means 3 plus x minus x square raised to power 8 as it is into derivative of first term, where first term is equal to 1 plus 4x raised to power 5. Now again if you will observe here, product of two term is there. That's why to find out the differentiation we are applying product rule. According to product rule, keep first term as it is, derivative of second term plus second term as it is into derivative of first term. So which is equals to, keep this first term 1 plus 4x raised to power 5 as it is. So we are differentiating this term. Since we are finding differentiation, observe the given function. It is in the form of f of x raised to power n. So again we are applying first formula to find out its differentiation. According to first formula, first take this power 8 as an coefficient. Then decrease its power by 1. 3 plus x minus x square, keep it as it is. We are decreasing its power by 1, so new power will become 7. Into derivative of f of x. What is f of x here? 3 plus x minus x square. Now observe the second term. Here keep this 3 plus x minus x square as it is, raised to power 8 also as it is. Now we are finding its differentiation. Again this term is in the form of f of x raised to power n. According to our formula, first take power as an coefficient, then decrease, because it is in the form of what? F of x raised to power n. So we have taken power as an coefficient, then decrease the power of f of x. Here f of x is 1 plus 4x. We are decreasing power by 1 into derivative of f of x. What is f of x? 1 plus 4x. So which is equals to, keep this first two term as it is. First write down the numerical value 8, 1 plus 4x raised to power 5 as it is, into 3 plus x minus x square raised to power 7 also as it is. Now we are finding differentiation of this term. Here first term is constant term, so derivative of constant term will be 0, not necessary to write 0 here. Derivative of x will be equals to 1 minus derivative of x square will be equals to 2x. So here differentiation is completed. Now observe the second term, plus keep it as it is 5u. First write down numerical value 5u into 3 plus x minus x square raised to power 8 also keep it as it is. Keep this term 1 plus 4x raised to power 4 also as it is. Now we are finding differentiation of this term. What is derivative of 1? Derivative of 1 is 0 and derivative of 4x will be equals to what? 4. So means derivative of whole term is 4. Now differentiation is completed. Let us simplify it. If you will observe this first term, nothing is there to simplify. Only we are able to change the order. If you want, you are able to write 1 minus 2x first. Then write down 1 plus 4x raised to power 5 into 3 plus x minus x square raised to power 7. अगर आप ऐसे भी रखते हो, at that time also it makes nothing different. Only just here we are changing the order. In the second term, if you'll observe here, take the here 5 into 4 will become what? 20. Keep remaining term as it is. 3 plus x minus x square raised to power 8 into 1 plus 4x raised to power 4. So this will be the derivative of this given function. So now observe the example number 3. Let us try to find out its differentiation. So differentiate with respect to x. So dy upon dx is equals to, at this time if you will observe this function, it is in the form of u upon v. Since the function is in the form of u upon v, so to find out its differentiation we have to apply this quotient rule. According to this quotient rule, first numerator will be u and denominator will be v. So keep v as it is into derivative of u minus keep u as it is into derivative of v divided by v square. Now first we are substituting the value in this formula. So dy by dx is equal to, keep v as it is. What is v here? Under root 7 minus 3x as it is into derivative of u. What is u here? X minus keep u as it is, means x as it is, into derivative of v. What is v here? Under root 7 minus 3x divided by v square. V square means under root 7 minus 3x whole bracket square. Just simply we have substituted the values in the quotient rule. So which is equal to, now let us simplify it. Now in the numerator, derivative of x will be equals to 1 and 1 into under root 7 minus 3x will be under root 7 minus 3x. Better way write down here, derivative of x will be equals to 1 minus x, keep it as it is. Now we are finding its differentiation. If you will observe this function, it is in the form of under root f of x. So we are applying this formula to find out its differentiation. According to this formula, its differentiation is 1 upon 2 under root f of x into derivative of f of x. So its differentiation is 1 upon 2 under root, this is root f of x. This whole term will be here f of x. So 1 upon 2 under root f of x. F of x is 7 minus 3x into derivative of f of x, that is 7 minus 3x. In the denominator, this square and this root will get cancelled. So what is remaining term here? 7 minus 3x. So which is equals to, Now, better way, this 7 minus 3x is in the denominator, so keep it as it is. Now observe this numerator. Here under root 7 minus 3x into 1 will be equals to under root 7 minus 3x minus here x into 1 will be equals to x, and derivative of 7 will be 0 and derivative of minus 3x will be minus 3. Means derivative of this whole term will be equals to what? Minus 3. Minus 3 into minus x will be plus 3x, and in the denominator 2 under root 7 minus 3x, keep it as it is. Just here differentiation of this whole bracket is equal to minus 3, and minus 3 into minus x will be equals to plus 3x. Now take the cross multiplication here. Let us see what we'll get if we are taking the cross multiplication. So 2 under root 7 minus 3x into under root 7 minus 3x. Keep these 2 as it is. Under root 7 minus 3x into root 7 minus 3x will be equals to 7 minus 3x. And here nothing is there, means 1 is there. 1 into 3x will be equals to 3x divided by 2 under root 7 minus 3x. Just simply we have taken what? Cross multiplication here. Let us simplify the numerator first. So which is equals to, see in the numerator what we are getting. So 2 into 7 will be equals to 14, and 2 into minus 3x will be minus 6x, and plus 3x, keep it as it is. And in the denominator keep this 2 as it is, 2 as it is. And if you will observe these two terms, 7 minus 3x, and here also base is what? 7 minus 3x. So since the base are same, then in case of multiplication we are able to take the addition of power according to laws of exponent. So here 7 minus 3x is the base, keep it as it is, 7 minus 3x. What is the power here? Power of this term will be, root means what? 1 by 2. So its power will be equals to 1 by 2. And here what is the power of this whole term? Nothing is there in the power, means 1 is there. And 1 plus 1 by 2 will be equals to 3 by 2. So here product of these two terms will be 7 minus 3x raised to power 3 by 2. So which is equals to, in the denominator 2 into 7 minus 3x raised to power 3 by 2, keep it as it is. Let us simplify the numerator. 14, keep it as it is, just we are collecting the like term. Minus 3x plus 3x will be equals to, minus 6x plus 3x will be equals to minus 3x. Now nothing is there to simplify, so this will be the differentiation of the given function. Well, seeing this example number 4, here given function is in the form of u upon v. So here also to find out the differentiation we have to apply the same quotient rule. So first we are substituting the values in this formula. According to this formula, first keep v as it is. V as it is means what? X cube plus 3 whole bracket cube as it is into derivative of u. So derivative of u is what here? X cube minus 5 raised to power 5. So v as it is, derivative of u minus u as it is. U as it is means x cube minus 5 raised to power 5u as it is into derivative of v. What is v here? V is nothing but x cube plus 3 raised to power 3 divided by v square, means square of this term, x cube plus 3 whole bracket cube raised to power 2. Just we have substituted the values in the quotient rule. Now let us simplify it. So which is equals to, in the numerator, if you observe the numerator, keep this first term as it is, x cube plus 3 raised to power 3 as it is. Now we are finding its differentiation. This term is in the form of f of x raised to power n. So according to first formula, first take the power of f of x as an coefficient. So we have taken power as an coefficient. Then decrease power by 1, x cube minus 5 raised to power 4 into derivative of this f of x. Derivative of what? F of x, x cube minus 5. See, directly also I am able to write down this derivative. Derivative of x cube is what? 3x square. But as far as board is concerned, these jumping steps are not allowed here. So you have to solve it step by step only. So minus x cube minus 5 raised to power 5, keep it as it is. Now we are differentiating it. To differentiate it, observe the given function. It is in the form of f of x raised to power n. So again we are applying first formula. According to first formula, take power as an coefficient, decrease power by 1. So what will the new power here? 2 into derivative of f of x. What is f of x here? X cube plus 3. In the denominator, according to laws of exponent, a raised to power m raised to power n will be equals to a raised to power m into n. So what we'll get here, x cube plus 3 raised to power 3 2s are 6. So which is equals to, now first write down here numerical value 5 into x cube plus 3 raised to power 3 as it is, here into x cube minus 5 raised to power 4 also as it is. Now we are finding its differentiation. What is derivative of x cube? 3x square. First take power as a coefficient, decrease power by 1, and derivative of this constant term is 0. Means derivative of this whole term will be equals to 3x square. Minus, keep it as it is, first write down 3, then x cube minus 5 raised to power 5, keep it as it is, keep this term x cube plus 3 raised to power 2 as it is. Now let us differentiate it. What is the derivative of this constant term? 0. And what is derivative of this x cube? 3x square. 3x square. Now in the denominator, x cube plus 3 raised to power 6, keep it as it is. So which is equals to, in the denominator, x cube plus 3 raised to power 6, keep it as it is. Now if you will observe this whole term, if you will observe here, can I take 3x square common from both the term? Yes, we are able to take 3x square common from both the term. Even we are able to take x cube plus 3 raised to power 2, x cube plus 3 raised to power 2 common from these two terms. Even we are able to take x cube minus 5 raised to power 4, x cube minus 5 raised to power 4 common from both the terms. So first we are taking 3x square common. Then we are taking here x cube minus 3, plus 3 raised to power 2 also common. And from these two terms, we are taking x cube minus 5 raised to power 4 common. So now observe the remaining term here. So we have taken these two terms common, and from this term we have taken square common. So here remaining term is 5 into x cube plus 3. Okay. And here we have taken 3x square common, we have taken this term also common, and from this term we have taken x cube minus 5 raised to power 4 common, means one term is remaining here, minus 3 into x cube minus 5. So which is equals to, keep this term 3x square as it is, x cube plus 3 raised to power 2 also as it is, x cube minus 5 raised to power 4 also as it is. Now we are simplifying this numerator. Try to understand here. 5 into x cube will be 5x cube, and minus 3 into x cube will be minus 3x cube. 5x cube minus 3x cube. 5x cube minus 3x cube will be 2x cube. Now collect the numerical value. 5 3s are 15, and here minus 3 into minus 5 will be plus 15. Minus 3 into minus 5 will be plus 15. So 15 plus 15 will be equals to 30. Divided by this x cube plus 3 raised to power 6, keep it as it is. So lastly, in the numerator, keep the denominator as it is, which is equals to, in the denominator what we have got here, x cube plus 3 raised to power 6 as it is. Here keep first term also as it is, 3x square. What is the second term? Just a minute. Keep this x from these two terms. Observe these two terms. Can I take 2 common here? If we are taking 2 common, 2 into 3 will become what? 6. So here we will get 6x square. Keep this second term, x cube plus 3 raised to power 2 as it is. Keep this next term, x cube minus 5 raised to power 4 also as it is. And from this last term we have taken 2 common. After taking 2 common, this 2 into 3 will become what here? 6. Since we have taken 2 common, so what is the remaining term here? X cube from 30, if we are taking 2 common, here remaining term will be 15. Means after taking 2 common, here we will get x cube plus 15. Now nothing is there to simplify, so that's why we can say that this will be the derivative of the given function. Well, now see the question number 5. In this example, this is the given function. And if you observe the given function, your product of 2 term is there. And since product of 2 term is there, so to find out differentiation, we have to apply product rule. According to product rule, its derivative will be equals to, according to product rule, keep first term as it is, 1 plus sine square x raised to power 2 as it is, into derivative of second term. What is second term? 1 plus cos square x raised to power 3. plus second term as it is. Second term is 1 plus cos square x raised to power 3 as it is into derivative of first term, where first term is 1 plus sine square x raised to power 2. Now just simply we have substituted the values in the product rule, that first term as it is derivative of second term plus second term as it is into derivative of first term. So which is equals to, here keep this first term as it is 1 plus sine square x raised to power 2 as it is. Now we are finding differentiation of this term. So observe, this term is in the form of what? F of x raised to power n. So according to our first formula, take this power as an what? Coefficient. Then decrease its power by 1. 1 plus cos square x raised to power, new power will be 2, into derivative of this f of x. Derivative of f of x means derivative of 1 plus cos square x. Okay, so now keep this plus second term as it is, 1 plus cos square x raised to power 3 as it is. Now we are finding differentiation of this term. So to find out its derivative, observe the given term. Given term is in the form of f of x raised to power n, means again it is in the form of first formula. And according to first formula, to find out its derivative, first take that power 2 as a coefficient, then decrease its power by 1, means new power of this bracket will be 1, not necessary 1 here, into derivative of f of x. What is f of x here? 1 plus sine square x. Okay. So which is equals to, now first write down 3 into 1 plus sine square x raised to power 2 into 1 plus cos square x raised to power 2. Now we are finding its differentiation. To find out its differentiation, first find out derivative of 1. Derivative of 1 will be equals to 0. Now we are finding derivative of this second term. Now if you will observe this second term, again it is in the form of f of x raised to power n, means cos x raised to power 2, means again it is in the form of first formula. According to first formula, first take this power as an what? Coefficient. Then decrease its power by 1 into derivative of what? F of x. F of x is what here? Cos x. Now again observe, it is in the form of f of x raised to power 2. We have first taken power as an coefficient, then decrease power of cos x by 1 into derivative of cos x. Plus, here keep first term, better first write down this numerical value 2. Again 1 plus cos square x raised to power 3 as it is, and 1 plus sine square x also as it is. Now we are differentiating this function. Observe this function, it is in the form of u plus v. First find out derivative of 1. Derivative of 1 is 0. Now we are finding derivative of sine square x. Again this term is in the form of sine x raised to power 2, means it is in the form of first formula. According to first formula, first take this power 2 as an coefficient, then decrease its power by 1 into derivative of sine x. Okay. So which is equals to, keep this first term 3 into 1 plus sine square x raised to power 2 as it is, 1 plus cos square x raised to power 2 also as it is. Here 2 into cos x as it is, 2 into cos x as it is. And what is derivative of cos x? Derivative of cos x is minus sin x. So derivative of this cos x is minus sin x. Okay. Keep the remaining term as it is, plus 2 into 1 plus cos square x raised to power 3 into 1 plus sin square x as it is, plus 2 into sin x into, what is derivative of sin x? Derivative of sin x will be equals to cos x. Okay, so in this way differentiation is completed. Now remaining part is simplification part. Let us simplify it. So which is equals to, if you observe this whole expression, here we are able to take 1 plus sine square x, 1 plus sine square x common from both the term. Again we are able to take 1 plus cos square x, 1 plus cos square x raised to power 2, 1 plus cos square x raised to power 2 common from both the term, and even we are able to take 2 sin x into cos x, 2 sin x into cos x common from both the term. So if we are taking 2 sin x into cos x common, so means we have taken this term on. Now this will be the negative term because minus appears here, and this will be the positive term. Now first we are considering positive term. Again we are able to take 1 plus sine square x common, 1 plus sine square x common, and from these two terms we are able to take 1 plus cos square x raised to power 2 common. So now observe here, we have taken 1 2 sin x into cos x common. We have taken this term also common. And from this term we have taken square common. So from cube we have taken square common. So one term is remaining here into 2. Means 2 into 1 plus cos square x will be the remaining term. Now observe this negative term. From this term we have taken, first write down this minus. 2 sin x into cos x already we have taken common. This term also already we have taken common, and from this term we have taken only one term common. So one term is remaining here, means 3 into 1 plus sin square x is the remaining term here. So let us simplify it according to double angle formula. 2 sin theta into cos theta will be sin 2 theta. Means here we will get sin 2x, applying what? Double angle formula. Here keep this 1 plus sin square x as it is into 1 plus cos square x raised to power 2 also as it is. Now I am multiplying multiplying by 2 to both the terms in this bracket. 2 into 1 is 2 and 2 into cos square x is 2 cos square x, and here term of sin square x is there, isn't it? Better way convert this cos square into sin square. Multiply by 2 cos square, but cos square can be replaced by 1 minus sin square x, and minus 3 into 1 will be minus 3. Minus 3 into sin square x is minus 3 sin square x. So which is equals to, keep this sin 2x as it is, sin 2x into 1 plus sin square x as it is into 1 plus cos square x raised to power 2 also as it is. Now first we are collecting the numerical value. So 2 and 2 ones are 2. 2 plus 2 is 4. 4 minus 3 is 1. Now collect the terms of sin square x. 2 into minus sin square x is minus 2 sin square x, and here minus 3 sin square x. Minus 2 and minus 3 will become minus 5 sin square x. Now nothing is there to simplify it. So that's why we can say that this will be the derivative of this given function.